last session. If you have any questions, just stop me. I have quite a few things to show you, but we can also explore left and right. Just ask. I don't want to bore you to death since it's quite late. So OpenTelemetry for logging. I assume that everybody knows what OpenTelemetry is, right? More or less. Because I didn't mean to do an OpenTelemetry overview anymore. It's just skip over that and just go straight for the logging part, more or less. If you don't know so much about OpenTelemetry or want to know more about the details, there is a great white paper, and hopefully the slide will reappear in a second. But the CNCF brought an observability white paper out that kind of like explains OpenTelemetry and the primary signals in it. So you have lower volumes, which is generally the metrics, which are aggregatable, and then you have higher volumes for traces, which are request scope, and then logs for the distributed events. And the white paper has a lot of more details. I can recommend that one. So the question is, why would we try to bring OpenTelemetry to logs? I assume everybody has logs. Maybe you don't have traces or metrics yet, but I assume pretty much everybody has logs in their application. Why would we change something that is working today? Or what are we even trying to improve or fix? The first thing is the unified routing of signals. So one of the strengths of OpenTelemetry is that you have one protocol and signal family, basically, that you can route together. So right now, if you have different logs, metrics, and traces solution, you will have different paths of the information and how to configure them and how to send them and how to aggregate them together. The thing here is that you have a unified data path that you can kind of like treat all of those together and joined. And the other thing is that you can correlate across them and use metadata from the combination and get more value out of the combination of traces, metrics, logs, and traces. So we want to get, for example, if you have a trace and you have a request ID, you might want to pull up all the logs for that request. So you want to have that tracing ID as part of the logs and to be able to do that correlation. So what we want to do is we want to have that integrated package. And how that looks like in routing in terms of signals, and I'll walk around here. So we have our Java, we have our application. I'll use Java because it's the most mature one in terms of like how to aggregate or how to instrument everything. We have our application that is instrumented with an OpenTelemetry agent. It will send out the tracing information. Maybe it has VM metrics, maybe it has custom metrics, and then you have your logging library that you're already using, and you want to take the logs from that logging library and also send it somehow out through OpenTelemetry. Or alternatively, you could write out a log file, and then you could collect that with the OpenTelemetry collector, which is this smart proxy that can also, for example, collect stats from the host or query the Kubernetes API. So the OpenTelemetry collector is like a centralized piece that can query additional information and then send it to your backend. And down here, everything here that comes out is the OTLP protocol, so the line protocol of OpenTelemetry that can then go to various backends. And one of those backends is Elastic, which I will use as my example here, but it could be pretty much anything that speaks OTLP and supports that. So the point here is that everything in this gray bubble is vendor neutral and just OpenTelemetry. And this orangey part down here, this is only where the vendors come into play then. And when we talk about correlations, we have our signals, metrics, logs, traces. Maybe you have profiling in terms of maybe eBPF. And you want to correlate those together. And if you have tracing, where you have a unique trace ID, the correlation is pretty easy because you could put that trace ID into your log event because those have a very clear relationship to each other. So correlating those two together is relatively easy. Where correlation is much harder is around metrics because your one request runs on a machine and that machine is serving lots of other requests. So you probably don't want in every request say like, oh, this was running, or you don't want to include like in the metrics like all the processes that we're running in parallel here, or the requests that we're running here. You don't want to include a request ID in the metrics that aggregates, for example, the CPU of a host. What you then do normally is, in terms of aggregation, is you use the timestamp and then something to uniquely identify that. So you will say, the metrics for the CPU usage for this process at this time is that and that much. And then you know that the trace and the log was also running in the same process and with the same, at the same timestamp, and then you can correlate them. And then you can correlate with profiling as well. So this is not as direct with an immediate ID, but here it's more like correlating on similar facts and grouping things together that might belong. So the link is not as explicit or direct, but you can do that. And this graphic is, by the way, also from the CNCF white paper still. So they describe the correlation part in more detail here. So this is what we want. And we mostly keep it simple today, and we'll look at this example. So we have tracing enabled. We want to take the tracing ID from OpenTelemetry and put it into our logs so that we can know where the logs combine. And then we want to kind of like take a look or decompose logs in terms of OpenTelemetry. So let's say this is what we have in logging. So we have our timestamps, and we have the log levels, and then we have some log statement, and then maybe we have a nice Java stack trace, and we want to break that down and see how that fits into the OpenTelemetry standard. What we have here is we have an OpenTelemetry span, and it knows the latency, it knows if that span failed or succeeded. It can correlate that with business analytics, and you could sample that as well. So this is how so this thing here is one span, so it's one unit of work. And then what we can add is for that span, we could say like, oh, this also has a metric. For example, this is okay as a log entry, but it doesn't make so much sense. Probably you want to transfer this into a metric, which you can then aggregate and roll up and whatever. And then you might want to add a span event. So this is like a log line within the span. So within that method, for example, you might have multiple events, and that's then an OpenTelemetry event. And this is in the context of this entire span and request then. And what you can then do is you can also attach an OpenTelemetry span exception where you actually attach this stack trace to that span. So this is kind of like from a classic log line, which is like one line at a time and doesn't really make much sense in combination, to mapping that to the spans and how they belong together from that level. Now, how do you get all of that out of your existing application with a logger? And there are three ways, and you will need to pick your journey, and it will have different trade-offs. So the first thing is we want to use our existing logging framework. So if you're using Log4j or Logback or whatever you're using, you probably want to keep using that. But you want to put that in the context of OpenTelemetry. So we have our application in Java here, and we're using Logback as our logging library. And we have instrumented our application with tracing and metrics, and they send the wire protocol OTLP out. And we then want to hook with OpenTelemetry into the logging library so that it can also spit out something that works for OpenTelemetry. And the first approach would be you do direct OTLP. And this is kind of like the best fit in terms of architecture because it's the most similar to the other two signals. But it's also the least mature one and has a couple of other trade-offs. So here, we're basically hooking into the logging library, and rather than writing it out to a file, we're taking the log lines and we add the tracing IDs and whatever metadata we want, and we send that out through OTLP over the wire as well. We don't have a log file anymore, but it's just over the wire. What is good or bad about this approach besides being immature? Yeah? Yes, so the stability, or sometimes I think it's also called flare, that something happens and you don't see what's going on. So the problem is, if your application starts and crashes very early on, it might not be able to send anything out over that OTel hook and send it to the receiver. Or if your receiver is down or your network is having trouble, you don't have any file anymore to look at. So the good thing about classic log files is that even if the network was down, you could just go to that machine or Kubernetes node or whatever, and you could look at the actual log file and tail that file, or you could just fetch it afterwards. That option is gone here because we are not writing it out to a file directly. So it needs to be sent over the network. The upside is you don't have log files anymore. So you don't need to rotate them. They cannot fill up your disk. You don't need to have that additional I/O overhead of writing the log file. So you kind of like just, send that out over the network. The second approach is you write the log file. You have a hook here so you can add the right metadata. You write it out to a log file. Ideally, it's structured, so we will write a JSON file. And then we can use the OpenTelemetry collector to actually fetch that file. And then the collector will send out OTLP here. So from this boundary on, it's kind of the same. But you need to run that collector on every node to fetch the local file. That is the trade-off, and you need to roll that out and manage that to collect the right files. But you have classic log files. The third approach is that you would say you write it all out and you have all the metadata in a log file, but you use another approach to collect the data. That could be, for example, FileBit or whatever else you use to collect your log files. As long as it has the right metadata here, that path from here on, it's not OpenTelemetry anymore. That is the downside. The upside is that these approaches have been around for 10 plus years normally and are more mature and stable than the others. But you can basically pick your adventure, like how it should fit into your architecture and how that all of that fits together. So far, so clear? Cool. I don't even want to touch this anymore. So, a couple of things. What is the status of logging and OpenTelemetry? So in terms of maturity, tracing is the most mature solution, and I think it's the de facto standard more or less for tracing at this point. Metrics are kind of, are reasonably stable, though Prometheus as an established standard is also very widely used. That's why it seems a bit uncertain right now if Prometheus will be the long-term winner or OpenTelemetry, or if the two will converge and then it's the same thing. Logging is the least mature of the three. It's also the earliest in its life cycle, or the least mature one, in part because everybody already has a logging solution, so it wasn't really solving any new problems. But it is, since a good year or so, logging and the data model are stable. If you're not familiar with OpenTelemetry, they have this status page which can tell you like what is the status of the spec, and for the APIs, the SDKs, and the OTLP protocol and the collector. And if we scroll down here, it will somewhere say logging. And the event API is experimental, but protocol, SDKs, and bridge are stable. But that's just for the spec and how the SDKs are defined. That does not mean the implementation yet. And in a moment, we're back. So this is the status of OpenTelemetry itself, and then it depends on the language how mature it is. So for Java, for example, even logging is marked as stable at this point. For other solutions, I think PHP, for example, for that one is also stable, which is almost surprising because they were often slow. But for example, JavaScript is still in development. There we go. So it's in development, but for example, if you're doing Go, you're out of luck. It's not yet implemented. So while traces and metrics are more or less usable across the ecosystem, logging is really very early. So this is more like, this is what you might want to use in the future. I'm not sure you really want to use all of this today. And I'll show you how you can implement all of those three approaches and what they look like in code. Do you want to see diagrams first or code? Okay, we'll start with the diagrams. Maybe this will make it easier. So, what have we implemented? So I have a very, very, very simple thing that runs in an endless loop and just logs statements out. And we have a function that is doing tracing and metrics, and then it's also logging. And the logging, for those of you who don't use Java so much, so Java has this concept of SLF4J, which is the logging facade. So it's kind of like the thing you talk to, but it's not responsible for what will come out at the end. That is the logging backend, that is logback in our case. So logback is then responsible normally for writing out that file or sending it over the network or whatever. So we are talking to SLF4J as we or as you always have if you were using Java. And then we add to logback that OpenTelemetry appender that can add the span information. It can add key value pairs. And then there is also baggage. Who remembers the concept of baggage in OpenTelemetry? Yes?
It's like linear through propagating through the system that's separate and not defined as a written in tag.
Yes, so you can add key value structured information on the span event, for example. But this one here propagates around, as you've said. So this is kind of like metadata that you keep throughout the request. And you want to potentially have this, or you want to have the support for both. That you want to have some information that you propagate throughout the request and have accessible, or you want to add key value information on the specific log event that you're generating. So all of those are running through here. They run through the OpenTelemetry instrument logging library, or sorry, the OpenTelemetry instrumentation library, and that sends out OTLP for logs, metrics, and traces through OTLP, and then to your backend, or actually could also send it to the collector in between. But this is what we are doing in this very first approach. So to show you just a tiny bit of code. So we have an application that is at some point starting up, and then it initializes OpenTelemetry explicitly, and then we have this endless loop, and it sleeps a bit, and then it does stuff. So here we add that baggage that we have a session ID, and then we call this function that does the logging at the end. So in this function, we basically have multiple options, and we try to combine all the different combinations. So we have a log message without the span, with a span and event, event and key value pair. So we do all of these things to make sure that all the features that you have in OpenTelemetry are also supported and can be correlated in your logs. And then at some point we scroll further down and we have our, so we initialize OpenTelemetry. That part is more boilerplate and less interesting. But at some point we have our do function, and here in that do function, if there's an exception, do this. And if there is with key value, then add a key value pair. So you can see this is how we add some structured information. So we have whatever key, and then we add the value 93. Or if you have an argument with an exception, then we add that. So this is kind of like combining all the different ways you could use in a log message. And then we have the logging configuration. So in logback, the logback configuration here, we say we have an appender. That is the OTLP one. This uses the OpenTelemetry appender. This will make sure that it doesn't write it to a file, but just sends it out over the network. And then we also say like, yeah, we want to capture code attributes, and we want to capture key value pairs and send all of this out. And I have this, let me start it. We want to run this one. So this one will run the application, and it will send the logs off. I will also very briefly, while this starts up, show you the collector configuration. So my application sends to the collector. And the collector takes in that all of the information for logs, metrics, and traces with gRPC. This is what this receiver is doing over OTLP, so this is just over the wire protocol. And then I define the exporter. In my case, I'm using the HTTP Elastic exporter, but you pick whatever your backend is. And then you say, I want to take the traces, the metrics, and the logs. I receive them through OTLP, and we log them, and then we also forward them to the backend. And if you have a different logging backend, or this is the only place where you have the specific vendor backend configured, and you can just replace that and plug in a different vendor backend on this one. And while I've been talking, ideally, or hopefully, we'll need to switch that to the logs APM index, because this takes in all the OTLP data. And while I have started this, we see we have 30 records for 50 total documents that have been received. I will open one that will appear in a moment. we have sent this with the OpenTelemetry Java agent in this version, and you can see this one here was a stack trace, and it knows it comes from this file name, and it has this class, and it's from file number 184, and it was called by the do function. So all of that metadata is there. It will also have somewhere, so you see where the stack trace happened and where it's coming from. It will also have the trace ID. So this will allow you then to correlate it with the tracing information because it shares those attributes. And then we have some other things like the timestamp, and my application is called Hello OSMC. And all of those have been added here. You see the transaction and the span and the timestamps, so we can correlate all of those together. And then I can jump to another event, and this one is a warn message, and it has the warning message. Okay, the message was error, which is maybe not so great for a warning, but you get the idea. You can provide whatever logging message you want to have. So this way we can just send all of that data. So much for this approach. So far, so good? Okay, let's switch to the second one. What was the second one? How did that work? Yes, write to a file and read from the collector. That's exactly what we're doing here. So again, we're talking to SLF4J. We're using MDC is map diagnostic context. That's the more or less the standard way in the Java world to have these structured key value pairs that you add. So you can add that. In this case, we need a polyfill to add support for that in logback. Then we write out a JSON file. We use the file appender to actually write the file, and then we read back that file with the file log receiver from the OpenTelemetry collector. There is, by the way, no standardized format for this. So OpenTelemetry defines what the fields are called, but there is no file format for this. So I'm just making up my own file format here, or you basically need to do that. So I'm jumping back to the logback XML. And what we're doing here is I'm using a file appender, so we're writing out the file. I'm using the logstash encoder. This is not logstash specific. This is just one of the encoders that can write out any custom JSON that you want. And I'm basically saying, this is what I want, and I want to put it into these fields in my JSON file. And then there's a polyfill appender that can kind of like polyfill some missing things right now. And we also have this OpenTelemetry appender to actually extract the key value pair. So you need to combine all of these things together to get everything into a file. And then the file looks like this. And nobody stopped me. I need to stop this one. So this is just a Docker setup that just brings up different configurations of the same application. And this will use the file receiver. So what you can see here is we have a timestamp, we have the version, we have the log message, and you can see the message is log message with key value, and then the logger is, I was running that in the past, so at the bottom there should be the OSMC ones, so these are the ones running right now, and you can see it is a warn and the level and a stack trace, whatever, so this is just a JSON file. This will be ingested by the OpenTelemetry collector. So here in the collector I say, I receive gRPC, this is for metrics and traces, and then I have a file log receiver where I say, this file that I've just shown you, the logs OTel log, should be parsed, it's JSON, and then you need to help that collector with some parsing, so you need to say the timestamp is in this format to parse it correctly, then we parse the attributes level into the field severity, we rename some fields to make them conform to the way that Kibana expects them right now, and then also removes a couple of things that we don't need. But you can basically collect all of that from the file, and then the collector sends it out over OTLP to the backend. And, sorry, that's the wrong window. And it looks like this. This approach so far, so good? Okay, cool. Last one. This one is very similar, but instead of using a custom JSON file format, Elastic has this Elastic Common Schema. It's basically a naming convention for the files and how to call the fields are called. So we have that built in and can write that out. And then we don't need to do so much parsing around it because it basically is standardized what it should look like and what the different fields are. And then here we are writing the file, but then rather than using an OpenTelemetry component, we are using, in my example, FileBeat to pick up that file and forward it. And this then skips the OTLP protocol. So this time we're not touching the OTLP protocol at all, or the line protocol or wire protocol. So what, and I should have shown you the output of the previous one actually. So it's in the same index because both come in over the OTLP protocol. But you will see in the structure there is a difference. So the agent name is now not the Java agent, but it comes from OTLP, so from the collector. But otherwise, it has the same field. So you can say it's still coming from the app Java and the do function and from this namespace, and it's collected from the OTel log. And then, well, this one is a warn and it has this log message, whatever, and then you can see all the fields of that log message. So that was the previous example. Let me stop this right away and start the FileBeat one. So this one is running the application and it is writing out a different log file. So this one is the Elastic log. Let me scroll to the end. And it looks relatively similar, but it has some small differences in naming conventions. So we have a timestamp, we have a log.level, which is info1, whatever. We have our message, and somewhere there will be a stack trace here, and we still have the span ID and the tracing ID because we have been instrumenting with OpenTelemetry, so it has all the necessary metadata to see those. And we can correlate those. So we have collected all the same information as before. This one then goes to a different index. This goes to the FileBeat index because I'm collecting it with FileBeat, and I didn't change the default, and it just started here. But what this log message then looks like is you can see the structure is a bit different because we have our own naming convention. But you see we have a log message with key value, and there will be a log level info, and you can see the logger and the line and the function and the path where we have collected it. It also has a couple of metadata or extra information pieces, like the inode of the log file that was being collected is logged here, and it's just structured slightly differently, but it has all the same information in it. So we have collected that. In terms of naming convention, there is one thing that we have announced at the previous KubeCon in Europe, is that Elastic Common Schema, the Elastic naming convention, and OpenTelemetry semantic convention will converge. So that's the OpenTelemetry naming convention, basically. That's still work in progress, and like adding new things that were not part of the other standard are pretty easy, but there are some breaking changes in there, and we're still working on resolving those. So that is still work in progress. But the longer term vision is that whatever an ECS appender will spit out, or an OpenTelemetry naming convention will do, that those two will match, and then you don't have to change any field names. So for example, for FileBeat, what I had to do is I have a FileBeat configuration somewhere here, and what I had to do here is, because the Elastic Common Schema convention has some naming differences, you see, and those are like stupid naming differences. One uses an underscore and the other one a dot. But it's still a breaking change. So we are basically taking trace underscore ID and rename it to trace dot ID, because those are those annoying small differences. And the one thing I have not shown you was the logback configuration. It's pretty similar to the previous one. The main difference is we have a file appender, but we have this ECS encoder, and that will know how to name all the fields and how to add those. And we have the same polyfills as before, where we have the key value polyfill, and then we have also that OpenTelemetry appender that knows how to add all the OpenTelemetry information. So in that regard, the second and the third configuration are relatively similar, and we have been collecting those. The one thing that I have not shown you yet is, what was the starting idea of why we were doing all of this? We wanted to correlate traces and logs. So I have this hello OSMC service running here. And you can see we have our one function that we are calling. And you can see that one here. And you can see that this one, for example, has an error. And you can, first, you can see all the metadata of like the session ID and the labels and everything that we have collected on this service here. But why did we do all of that correlation? Because we wanted to say, show me the logs for this trace. So I filtered down to that trace ID, A0, whatever. And then it says here we had an error, and then we had an hello OSMC, one log message, whatever. So these are all the log messages for this one trace ID. And this is kind of like the correlation that we wanted to reach here. So far, so clear for this use case.
Is this correlated to the spam, or is it correlated to all logs with this trace ID?
No, so this is filtered on the trace ID.
So if I have tens of applications included in one trace, I have tens of different logs.
Yes, you can correlate. So you can pull the logs for the entire chain of, or the entire request. That's kind of like the point. So, and it might be very helpful if you say like, oh, this request ended up in an error, and I want to pull up all the logs for this one request. That's exactly the point that you want to have here. So you're not losing any of the features that you had with your classic logging. You didn't have to rewrite anything in your application. It was more only the configuration in logback that you need to change to tie all of the things together. And then you need to decide which one of the three different approaches you want to use to write out your log messages. Just, we are doing well in time. Just as a reminder, these were the three different options that we have looked at. And then you need to pick, do you want to this one? And this is future looking, potentially an interesting one, because it fits the architecture the best. If you're very concerned that you might be missing out on local log files, you could also do this and also maybe two, or you could also write the log file. You will have some extra overhead of writing the log file and sending it out through OTLP, but even if there is a problem with sending out the OTLP information, you will still have the log file. Because in my example, I'm actually doing all three things in parallel. I have configured my logger. So in my example here, I have basically configured my logger to do all three things, which makes sense for a demo, but it's not what you want to do in production. But you could, if you want to, do two things. So send out over OTLP directly and log to a file just as a backup. Your decision of what is easiest or makes most sense or is doable in terms of resource use. Yeah, that's the idea of logging with OpenTelemetry. And I will say that I find it not super mature yet, and I'm not sure you really want to do that in production today. But this is where things will be headed over the next month, quarters, whatever, and what hopefully then makes it easier to tie all the different signals together, allow routing of OTLP over one way and not have like different things that you need to take care of and that work differently. Any questions? Who wants to use this tomorrow? Okay. Great that I have convinced you. Let me know how it's going.